Today we're looking at what is infrared. We're going to discover its radiation, its heat energy, and anything with a temperature above 0 Kelvin will be radiating infrared. So the ice cream, the chocolate flake will be a different temperature, your hand will be a different temperature, but each of them will radiate infrared. And indeed, the sun radiates a lot of infrared, and that reaches the Earth. It was discovered 1800. William Herschel was looking at the temperature of visible light, the colours of the rainbow that make up visible light, and he discovered a thermometer just to the side of the red colour got even warmer. He had discovered infrared, and there's a link to a video tour there at the bottom. And you can see colours of the rainbow. You need moisture raindrops to be able to split the white light, the visible light, into the colours of the rainbow. And indeed, infrared will be to the side of the red, but you cannot see it with your eyes. But you can feel infrared as warmth. Infrared's different from visible light, but it's made up of waves. And just to look at sunlight, it can be split by a prism, by a raindrop, into the colours of the rainbow. And that's thanks to Isaac Newton. And those different colours of the rainbow have different wavelengths. And indeed, infrared has different wavelengths. So on the reddy pink line on the left side, you've got the far infrared. To the right of that, human hair size, you've got the thermal region, and to the right side, you've got the near infrared, and that would be adjacent to the red of the visible light. And a reminder about wavelength: it's a complete circuit on a wave from the same point to the same point, here shown from crest to crest, but it could go from halfway down to halfway down the next one. And you've got the wavelengths there, and infrared wavelengths are longer than those of visible light. And just for the curious, those waves are made up of packets of energy called photons. And here's an activity: 2 people holding a rope, one holding a hand still, the other person raises it up and down reasonably fast, steadily, producing waves. And now let's move the rope faster, same height up and down. What do you notice? And which required more energy? And how do you know that? That's going to apply to our waves as well. Here you've got the colours of the rainbow, the visible region of the spectrum, and on the left side you've got going into the infrared region. And here, looking at the wavelengths, getting larger to the left, getting smaller, shorter to the right, and beyond the violet, you've got ultraviolet, X-rays, and gamma. The gamma rays have a wavelength about the size of an atom's nucleus. And to the left of visible light, you've got IR, then microwaves and radio waves, which can have wavelengths kilometres long. And how can you see IR? Using heat sensing cameras, and you can look at these pores to look at each of these images. And indeed here you've got a fireman using a thermal imaging camera and looking at a house, looking at your hand, which if you do the activities you'll see heat sensor there. And here you've got a dog, and then you've got an IR image taken actually from an airplane, Sapphire, to get above most of the Earth's atmosphere to get an IR image. And you see past the dust cloud and to the star-forming heart of the galaxy. So what is infrared? It's heat energy. Anything with a temperature above 0 K will emit infrared energy. And looking at that image there, what are the hotter parts? Why are those red parts seen as hotter? Why are the blue parts seen as colder? And what do the yellow parts tell you? And to find out more, pause this and you can look at more of the activities on the Smithsonian Learning Lab that's described here.